This is Steel Shorts with the American Institute of Steel Construction. Quick stories about the integration of architecture and steel structure.
My name is Mark Ramirez. I am the Managing Director at Hickok Cole Architects in Washington, D.C. We are the executive architect for the Spy Museum. Stirk Harbour Partners is the design architect. I'd like to start by asking a question. Why is it important to build a museum dedicated to spycraft? We just have to look at the news today to see how integral spycraft is to the world we live in. Not only is spycraft important today, but it was important at our founding. As one defeated British officer is often quoted as saying, Washington did not really outfight us, he simply outspied us. Our nation capital needed a museum to commemorate and honor this important legacy. So the Spy Museum chose a location near the monumental core in between the mall and the wharf. The concept for the building included two important features. First, the black box. And this is based on all the covert activities of spycraft. NSA, spy satellites, data mining, etc. The second concept is that of the veil, which represents spycraft that is around us and that in theory we can see. A dead drop, human intelligence gathering, deep throat. The interplay between these two elements represents the hidden and the hidden in plain sight. So when you visit the museum and after leaving the lobby, the experience begins on the 5th floor where you walk through the exhibit spaces in the black box. As you move down through the building, you increasingly interact with the veil, each time experiencing it more and more until you return to the ground level. I'll talk briefly about the context of the museum and its location. It is located on 10th Street, L'Enfant Plaza Promenade. The Capitol Mall and the Washington Monument are to the north, and to the south is Banneker Circle and the new wharf development. From an urban standpoint, this is the midpoint between the mall and the water. As a civic institution, the building was viewed as a way to draw people from both directions. Below the Spy Museum is 3 levels of parking and an underground food court. We like to call this a building on top of a building. This is the main reason for the sloped columns, the need to utilize the existing column grid, but also a desire to project out into public space as a visual marker for visitors walking down the promenade. As the executive architect, Hickok Cole was responsible for jurisdictional approvals, project management, construction documentation, and of course, construction administration.
Hi, everyone. I'm Dan Cacciardi with SK&A Structural Engineers, and I was the structural engineer for the project. As the structural engineer of record, SK&A was responsible for the structural design of the museum superstructure, including the various stairs and platforms within the glass veil, as well as the strengthening of the existing concrete structure below the museum. SK&A oversaw structural coordination throughout all phases of the project, from concept design through construction. First, I wanted to talk a little bit about how the use of structural steel helped with site gymnastics and the complicated existing conditions. The existing 4-story concrete structure, which underlays the museum, includes retail and parking spaces and was not designed to anticipate a 130-foot tall museum above. As such, strengthening of the existing concrete structure was necessary to support the new loading. The use of structural steel allowed for us to have long-spanning exhibit spaces, and it reduced the weight of the museum structure since it's lighter than concrete construction, resulting in significant cost savings for all of the strengthening required below for the project. The existing foundations and columns were strengthened, and transfer beams were built prior to the museum construction above. Due to all this, careful schedule coordination was required due to the work done over and adjacent to occupied space. The glass veil is one of the most important features of the project. The brightness of the veil, in contrast to the protected black box, was important to the overall concept of hidden in plain sight. The veil needed to float and project with elegance while the structure navigated the awkward site conditions. This required close coordination among the architects, engineers, and steel fabricators throughout the entire process. The sloping red columns that you can see here are part of the primary structural frame. With steel, we could design these sloping red columns to carry the load of the museum floors, the veil, and the stairs, and still maintain their sleek aesthetic. As you can see, the column profile starts smaller at the top near the roof where the load demand is less and gradually gets larger by level 4 at point of highest load demand, where they attach to the vertical pin columns and that load gets carried down to the base. This is an example of the architectural form following function. The minimal sloping red columns are exposed and highlighted with intumescent paint, which also provides fire resistance. The glass veil is supported by tension rods that extend to the top of the sloping red columns and is laterally braced with Y brackets that extend back to the building's superstructure. The various stairs and platforms are constructed out of exposed steel shapes and supported by hanger rods and pin connections throughout the space. Due to all of these connections of the different members, the stairs, the veil members, there was a lot of coordination required between steel fabricators, engineers, and the architects throughout the project, which became very important in the veil space in particular. This required shared digital models, numerous coordination meetings, site visits, site surveys, and shop visits by all parties in order to work out all of these details.
Hi, I'm Chris Gregory with SteelFab. We're the US-based steel fabricator on the Spy Museum project. A fabricator's role on a project such as this is to take the separate steel elements involved and work through the constructability, both in the detailing and production stages before it's erected on site. We have to do this to maintain cost, overall budget, hit the schedule, and also do this safely. Because of the complexity of the project, we use an intensive design assist collaborative process. It's when trades like steel fabricators are brought in the project during the early stages in order to work through the critical details and speed up the schedule. In order to get some of the elements like the pin connections on the red sloping columns, we did large mock-ups for the team to make design decisions down to the location of the bolts and a variety of finishes on the exposed steel. The initial design intent called for some large pin connections, which when we worked through the design team, looking at the reactions involved and how those were not quite as construction friendly as we would have hoped, we ended up pivoting to some bolted connections that still satisfied the architect's intent. We had to refine the details and coordinate with other specialty fabricators on the project, as well as a number of other trades and designers. Some elements like the hangers and the veil were assembled in the shop, and some others were done in the field. Tolerance, which is the space provided for some construction flexibility, was important for the veil's curtain wall assembly. We worked with several other trade contractors, both in the US and abroad, to dial in some of these tolerances down to the millimeter. Using structural steel not only reduced the actual weight of the structure while providing flexible long spans needed for changing exhibits, but it effectively reinforced the overall concept of the museum.
For more information for students on a steel cheat sheet, scholarships, competitions, and more, see aisc.org/archeducation.